It's on.
My progress at the moment is I was struggling earlier with getting my IMU to give me results that were understandable, and so I've made progress in that space. So I've got my BNO085 using a example running on the Nano using this command, the get yaw command out of a SparkFun library, and if I take that result times 180 divided by pi and point it east, I get a 0. Point it north, I get 90. Point it west, I get 179 or minus 179, and then point it south, I get minus 90, and I was able to do that, inside the house in a fairly noisy environment. I mean, and so certainly more testing is needed, but feel pretty good about the fact that I was able to calibrate it using a document that was put out by these guys, which is the manufacturer of the sensor. Although this says BNO80, it actually worked for the 85 as well. And they go through this, what's reasonably typical process of, they used a headset, which was actually useful because it sort of visually is a little bit easier to understand about. Well, I'm not sharing my screen. Guess that would help. Now I think you're seeing my screen.
Yes, I am.
This is the document. The link to the document is here. I also was sharing, this is a little cheat sheet that I made just to make it easier for me to show what I was expecting and what I was getting. But anyway, the SparkFun command and my result, getting a 0 going east, getting a 90 going north, 179 or minus 179 going west, and minus 90 going south. But then this calibration document put up by Hillcrest.
Yeah, I was reading through that, and I thought they said you run this and it'll store it to EEPROM and everybody's happy. But I was under the impression that chip does not have EEPROM in it. So I don't know. Again, I'm confused by this document you pull up, because I don't know if they're talking about the chip itself or if it's a board that they're selling that has extra stuff on it. So I'm always a little confused when I look at this stuff from Hillcrest.
Yeah, well, I will tell you what. Let's see if I can find it quickly on. What I exactly did was. SparkFun provides a series of examples, and where's there? They have a in one of their examples, they actually have a set calibration. Well,
So apparently the Spark Fun code that they gave you has a way to store the calibration on your local EEPROM on your Nano, then apparently.
yeah. And so that's what
and does it look like that when you start it up the next time, does it automatically load that stuff in and it's all calibrated, ready to go?
Yep, I've, multiple times it comes back in a rather noisy, I say noisy, but I would imagine it be prone to interference. It starting it up in different positions and whatnot. It comes back to being reliable and providing a high status. So it refers to it as DCD memory, dynamic calibration data to memory. I didn't dig into exactly what register or whatnot that it's storing. Or go look at this save calibration. What would you call that, a function?
Probably, I don't know. Yeah, I'll have to read through that page you've got there and see what their procedure for doing it is. Because on mine, on the BNO085, I found that the Adafruit library for that one of their examples is I think it's called restore calibration or something like that. And basically it's a program, it's just an example program to show you how to do it, but you load it onto your device. And I've got a Teensy 3.2 and it would probably work on, a Nano. But basically it says, it starts up and looks at the EEPROM to say, do you have any calibration data stored already? And if not, it puts up a thing, say, okay, do these steps to calibrate it. And it just simply watches the calibration results. For each sensor, it gives you 0 to 3 for each one. And 3 is the best calibration you can get. So there's one for the gyroscope, one for the accelerometer, and one for the magnetometer. And plus there's one called system calibration. I don't know what that one is, but that's also a 0 to 3. But this code apparently just watches, and when all the numbers equal 3, it just immediately grabs all that calibration data and writes it to the EEPROM and then goes into normal mode. So then next time you start up this program, it says, is there data in the EEPROM already? And if there is, it just loads into the board and starts running. And I was thinking what I need to do is just take that example program and hack it down to the point where I can get, basically I'll just have a calibration program. I start it up, it runs the calibration and stores it. And then on the code that actually runs, put the part that says, if there's stuff in the EEPROM, go ahead and use it. And that seems like it's kind of a roundabout way to do it, but I think that will work. The other point was I noticed on the BNO055, of the 3 types of sensors in it, the gyroscope basically says if you just let it sit there for X amount of time, it'll automatically calibrate itself. And it doesn't even have to be laying flat or anything. It says as long as the angle is steady, so as long as you have it somewhere, so it's not moving, it'll go ahead and do its calibration. And so that's actually simple enough. Every time you start up, you could rerun that calibration just to know that you've got the correct data. And then for the accelerometer, that one, again, depending where I read, if I look at the Adafruit site, it says, well, you got to put it in all 6 positions. So you got your, we'll say this is the thing I'm running here. And if it's laying flat like this, the X and Y should say 0, and then your Z up and down is going to give you 1G. And I can never remember that's positive 1G or negative 1G. But anyway, that's one position you need to do one of the Z, and then you flip it over like this. And that's the other position for Z. And then you turn it up like this. And that's the position for, I guess that would be X. And then you flip it this way for the other X direction. And then you flip it this way for Y, and then you flip it this way for the other Y direction, at which point that should fully calibrate it. Now I was looking at the Bosch documentation, or they even got a YouTube video, and they basically just have it laying on the table like this, and they say, okay, to calibrate it, you just have to move it. You just have to move it in 45-degree increments. And he would move it and let it sit there for a few seconds, and he'd move it again and let it sit there for a few seconds. I don't remember if he went all the way around, but he was only calibrating in one axis and doing it 45 degrees at a time. So anyway, back to my point. It tells me two different ways to do it, so I don't know which one is right. So I was thinking what I could do is I could calibrate the accelerometer any way I want to, basically just put it in those 6 positions and it'll say it's okay. And I'm thinking if I just then dump out the value from that I can put that value back into my my main calibration program. So I could write down the values for the gyroscope, write down the values for the accelerometer, so then have a separate program that starts up. It knows what those values are already, and then it's just going to try to calibrate the magnetometer, at which point then I can start picking my robot up and moving it around and try driving it on a hill or whatever, like I was talking about before. And then once it reaches its calibration point, it could say, take the values from the gyroscope and accelerometer that is hard coded in, and they take the values they just created and write all that to EEPROM. So again, it's kind of a roundabout way to do it, but I'm thinking that I can do it in 3 separate steps there and come up with a way to do it, so I don't have to get real elaborate to do an actual calibration. And I haven't got around to trying that yet. I need to hack that program up and see if I can make that work.
Yeah, I mean,
although it does seem like, if I run that program and it says save the calibration data, and then I come back later and start it back up again, it does seem to load the calibration data and it thinks it's happy. And I haven't done any testing to verify if it's being correct at that point, or if I'm going to have to do something else to make it work. So I'm not sure on that.
I have to admit that this was the easiest calibration. I mean, I've been through the torture of trying to calibrate these things before as well, and this was the easiest that I mean, between SparkFun's code and this instruction, it was, I was a little bit dubious. I mean, here they're saying that's for the accelerometer, and a little bit further they say this is calibrating the gyroscope, and then they say here's calibrating the magnetometer, and everything's done now. Just press the DCD command. I was a little bit dubious if that was all going to work, but boy, oh boy, it sure seemed to make it clear. And as you note, if you watched the video, you had asked me about the odd position of the placement of the module, and now it's lined up straight as well, following the stencil on the top of the unit. So yeah, progress.
So when I was digging into this calibration, something else came up. It turns out there's something called a fast magnetic calibration or not. And I don't know what exactly that's doing, but that's something else I can look into. And something on the BNO085, I think it said you might want to turn off the automatic calibration, the automatic background calibration, because otherwise if you're driving around, it said something about may decide to recalibrate on the fly, and that's going to screw up your numbers. And I'll have to see where I found that, and I can point you to that.
Thanks for
that.
that.
And that maybe in that SparkFun code, they might even talk about that. So I haven't looked at that, the SparkFun code that you're using on your device right now to know what's in there and what's not in there.
Well, speaking of code, so the next step for me is to try to figure out, okay, so if this thing is calibrated, how do I use it in a ROS sort of setting? These guys, they have a driver that they've created for, I mean, they sell a unit, $80 unit based on, I think that's based on an 80. I don't know if you can see that, but it's based on a BNO085. And they've put a USB output on it. I don't know what sort of microcontroller they have in there, but you know, they've installed an FTDI chip in there and giving you a straight up USB output. But in the process, they've also provided the source code for reading it. So I was messing around with trying to actually use this, and at the moment, my compiler is not able to compile this. So first it didn't find that library, so I moved that library in. And then what's my compiler complaining about now? Oh, when I go to that, it didn't find, what else didn't it find? It didn't find Ross. Like, it didn't find Ross. Well, that's odd. So I'm fighting with just getting their code to compile. Just to see if I can get it to output anything.
Did you download this as a Git clone, or did you download the zip file, or how did you do that?
I did not Git clone it. I just copied the.
Because I'm thinking if you do a clone, it's going to have all those extra files are going to come along with it. So maybe that would work better.
Yeah, that's a good suggestion. I'll try that.
Might be worth a try, and then at least you'll have all the files right there. Now, keep in mind, this may or may not have a microcontroller in between with what they're doing. It could be that they've taken them, they're not using the microcontroller, their FTDI chip connects directly to their sensor board, and the software is all written to talk directly through the UART directly to your chip, which means you could leave out the microcontroller, or it could be they've got a microcontroller built into their box, in which case then you'd have to know what the format of all these messages is coming in and out, because you know, if they've got something loaded on a microcontroller generating messages they're expecting, then that would probably be a lot of work to figure out what those are and convert those. I think I did see another somebody else's code that was a ROS driver for, I have to check to see if it is for your chip or not, but somebody else had written a driver that will talk just over a UART to the raw board. So I'll see if I track that down. I can post that.
If you do stumble across that, that would be great. I was, I mean, when I saw that, I'm like, oh, well, that looks like they're reading well, I had high hopes that this might actually compile but compile and reading it off the, I hear what you're saying about the FTDI chip, and yeah, reading the hardware is a whole big another kettle of fish. So anyway, I was trying to get the data off the board and get it into ROS is where I'm at the moment.
But if this is designed to talk directly over the UART directly to the chip, then that leaves out one whole level of extra complication that you have to get to work and maintain. So, and I don't know how much digging you'd have to do on their information to find out which way their device actually works. If it is just a plastic box with that single chip in it and a FTDI adapter you plug into the UART or plug into a USB. You know, they could do it that way, or they could do like everybody else does and put the extra microcontroller, either a Arduino Nano or a TNC, whatever, in between there. So that's two different ways you could run all this stuff. So it's just a matter of, you know, how they designed this to work.
I guess the other thing I could do is just cut out all the code and just see if I could get something like this connection to work, and then add the next module to it. Just get something simple to actually communicate to the board and go from there.
And it might be simpler to dig through this code where they say, okay, we're going to talk to the board, we're going to send this message out and see if the message looks like a Bosch IMU message, or if it looks like something that they've got an intermediate processor they're talking to. If it looks like it's actually reading and writing directly the registers of the chip, then you probably don't want a microcontroller in between to get that to work. But if they're creating their own custom messages, then they probably do have an extra microcontroller in there. So even without running the software, just dig through there and see what their messages look like that they're sending back and forth, and see if you can tell from that which is which.
So anyway, that's where I'm at.
But if I can find the link to that other one, I was thinking that I might have. They said specifically this talks directly to the chip over an FTDI adapter. So they're telling you right up front. You don't have to guess which way it is. They're saying that is the way that works. And it could be that, in fact, that one you just posted for the BNO085, that's the way that ROS driver works. So they're talking directly to the chip through an FTDI adapter. And this other stuff that I found, I'll have to go verify, see which chipset it's for, if it's for the 55 or the 85. But if they tell you right up front, it is the UART mode, then that should be, then you know ahead of time what it is, and you hook it up and set the right jumpers on your board, and then away you go. Now, I don't know how they're going to handle the calibration, but that's something else, because then your ROS node would then have to do the calibration, because that's the only processor you've got running now, is that, you know, it's on your Linux machine, it's the ROS node, so you'd have to see if that's got calibration in it to take care of all that. So anyway, it's just more stuff to figure out.
Cool. Well, if you stumble across it, let me know.
Okay.
What else is going on in your world besides internet and beef?
It's supposed to get hot again the next 2 or 3 days, so I turned my air conditioner on. Oh, yesterday my power was out when I woke up yesterday. I didn't realize the power was off, but I thought, I woke up and, oh, it's so peaceful, it's nice and quiet, and I thought, oh, I must have turned my air conditioner off before I went to bed, and I laid there for a while. Then my air conditioner started up. I thought, oh, I must have found an option that when the temperature, because normally I thought when I turn my air conditioner on, the fan runs constantly, and then when it gets warm enough, then the compressor turns on, and then the compressor will turn back off, but the fan runs all the time. And I thought, well, I'll have to look when I get up to see if I did something funny to it. And then about then it turned off again. I thought, what the heck? So I thought, well, I'll have to look at that. I'll have to get up and get ready and look at it, and turn around and looked at my clock thinking, I wonder if my power's off. Looked at my clock. No, my clock was blank. It's one of those LED clocks. So I realized, no, I had no power. And so I went to the bathroom, turned the light on. There's no lights. And so I got around in the dark, and I finally got everything going, and they had it fixed within. It turns out they're sending emails the whole time saying, oh, your power's out, and power's out in this area, your power may be off, here's our estimate. And finally said, oh, power's back on. So it came back on, and everybody's happy again. And now today, all my lights flicker every time the neighbor's air conditioner turns on, and you can see it. You can see on my picture every once in a while, you'll see it. You'll see everything flash because the light dims out and comes back up. So I don't know if that's. I thought in the past I'd seen my lights flickering, and I figured it was either the air conditioners or my power's about ready to go out. Well, now the power has gone completely out. So if it was connections, they probably fixed all that. So anyway, that's just my life now. That's just the way things are going to work, and I just won't worry about it.
So no more testing in the yard with your robot?
I haven't done any other than, as I say, I was looking at that code. that loads does the calibration stuff. And I decided I needed to hack that. I did take that out and actually ran it outside. I think or did I do that? No, I didn't actually put it on the robot and run through the calibration. I could have done that, but I didn't. If I'm going to do any actual calibration, I should bolt the thing down solid instead of having a rubber band holding it on. So every time I turn it on, it's going to be that if the calibration stuff works, then it should be ready to go then every time. Oh, there my lights just flickered, but you weren't watching. So in my screen, you can see my whole screen flashes when it does that.
I didn't see it flicker.
Wait, that's because you're looking down.
I know, but it must have been fast.
Well, it's real fast, yeah.
I'm surprised you didn't drop your connection.
But it's not. It doesn't take the power down all the way. It's just the lights they just blink. The lights just blink a little bit because it just drops it just enough to be noticeable, and it doesn't take my power out completely.
So for heading, what are you thinking you're going to use for heading?
Eventually, well, let's see. Right now, I can get heading from my dual antenna GPS, and if I want to, I can get heading from my just single antenna GPS. I figured out how to decode that velocity message, so I can get the speed and the heading out of that. And if I take the speed and say if you're less than say 1/10 of a meter per second, latch that value, so I can do it that way. And it looks like this Bosch sensor may be good enough to put out a heading. So it really comes down to the question of what are you trying to do? As Javier said, he's looking at trying to merge, like everybody in Ross says, you should merge your GPS and your wheel odometry and your IMU together with a Kalman filter, and that's going to solve all your problems. So I'll have to look and see, because you still have the problem if you're driving along and your GPS quits or drops back to a lower level. Is the stuff smart enough to take it from your IMU and take it from your wheel odometry and still give you a decent heading for either X amount of time or X amount of distance? So theoretically, that stuff is all supposed to be smart enough to switch back and forth if you're using that robot localization node. Oh, there my lights just did that again. If you're watching the screen at that point. Because I can see my image on the screen. I can see it when it does that. So anyway, and in reality, I'm still just experimenting with all this stuff to make sure I can get decent values out of everything. And then I can start throwing it I'll have it to the point where I can mix and match. I can say, well, I'm going to use robot localization or not, or say, do I just want to take the GPS and use its X, Y, and heading and use that directly, or do I want to use wheel odometry or ignore that completely? So I can just, by starting up different nodes, I can pick and choose what I want to do, and that way I can, pick an option, go drive around the block, and come back and say, how well did that work, and then try something else. So that's still kind of where I'm at. I'm just at the point where I need to say, okay, now I've got enough sensors running, and start picking and choosing which ones to use, and decide if I need to fuse those together or not.
In your wheel odometry, did you figure out you mentioned that you were I don't know, your wheel odometry data seemed to be giving you a number that was different than your, my words, not yours, your calculated heading based on wheel odometry was giving you a number that didn't seem like it was jiving with.
The problem with wheel odometry, it's put it out in ROS terms, and GPS puts it out in GPS terms, and one is like rotated or flipped or something, so that there's an issue with that. The other issue is when I was just driving around my front yard, so I go a very short distance, all of my odometry looked pretty good, but when I drive all the way around the block, it gives me an expanding, instead of coming back square like this, it gives me something that looks like this, because my calibration is off on that. And a couple of years ago, when I got on the Ross Agriculture meeting and said, well, here's my Excel spreadsheet and here's my odometry, driving around the block, and it's wrong, but if I go change these values, I could get it to pull back in and look pretty good. Well, apparently I didn't put those calibration numbers back into my robot, so I need to go back and either drive around the block and recalculate everything and put the right numbers in, or I should come up with some kind of an automated thing where I say, calibrate the wheel odometry and have it either drive in some pattern or or drive straight or whatever it needs to do, and have it automatically come up with those numbers, because that would be a much better solution than having to, get this big bag file of driving around the block and then try to recalculate everything and find out what the right numbers are to make that work. So that's yet one more thing I need to do.
I do
But
think
in
I
general-
saw your light blink about 10 seconds ago or 20
Yeah,
seconds ago.
Yeah, they just do that. And the other problem is I've got LED light bulbs, and the LED light bulbs are sensitive to the change of the line voltage, and that, because I think if I just had a regular incandescent bulb, I wouldn't see that. But the very first thing today, I came in this room and I heard a thump of an air conditioner starting up, and at the same time the lights flashed. So I realized that's what's causing it. A couple of weeks ago, my lights were flickering and I didn't know if it was air conditioners or not. But now I'm pretty sure that's what it is. I'm sure it's just my neighbor's air conditioner turning on and off that makes it do that.
That's really, I mean, they're just pulling some serious amps or something. I don't know. I mean, the motor might be going bad or something.
Well, it's just a combination of, oh, there, just did it again.
I know.
It's a combination of the motor starting and then the fact the LED bulbs amplify the fact, the fact I've got those two together. I think that the LED bulbs are just getting cranky because they didn't like what it was seeing. And it could be that I am going to have, it could be my power's going to go out again.
Interesting. Hook up a scope, see what's going on in your scope.
I could do that. I got a scope sitting right here, and I can now hook it right up to the computer. I had the scope for like 2 or 3 years, and I kept thinking, boy, if I could just do a web presentation and show my scope. Well, it turns out there was a disk that came with the thing, and I just never loaded up. And you could hook up an Ethernet cable between the scope and the computer. So I can just start up a little, it's a fairly crappy little program, but it does work. And I start it up, and it just gives me a window that shows me what's on the scope screen. So theoretically, yeah, I could do that. And it's a fancy enough scope. I can like slow it down and do it, like a scrolling thing, so I can watch the things over time. So I could do that. I just don't have the ambition right now.
Okay. Well, what's on the docket this weekend?
I should look at that calibration software some more and try to figure out, do I need to make 3 separate calibration programs or just one? And if I can just come up with the numbers once and then put them into my code that I'm already using. So it says when it starts up, says if there's calibration data, use it. And if not, I don't flash the LED or something. I don't know what it's going to do. Flash it so I know that it's out of calibration. So I don't know. I might do that. Oh, I did. Also, like a week or 2 ago, when I was added on that steering sensor Arduino, and I thought, well, I'll plug it into the computer, and I wanted to plug it into another USB hub. Well, it turns out I lost one of my USB hubs. I had 2 identical ones, and there's one in my GPS box that has the 2 GPS receivers and the 2 IMUs plugged into that one. And I was going to put another one into my electronics box, because right now there's just a cable that plugs into my eval board. So I wanted to put a hub there and then run my eval board and the steering sensor off from that one. And I couldn't find that USB hub, but then I was cleaning crap out in case the cable guy showed up or the phone guy showed up. There it was. I kept thinking it just fell down behind something, and sure enough it did. So I found that. And the other problem with that one was you plug the cable into the hub. It's got a removable cable for the input, and it's the cable doesn't fit tight enough that'll hold it in. So every time you look at it, that cable falls out. So this time, before I did anything, I found my hot glue gun and glued it so that can't pop out. And I went and put all that together. So now I need to go back and do my, I have to hook the computer up and look at dmessage and see what those 2 things initialized as, and then go change my UDEV rules so it knows that those 2 devices will always be on those 2 ports. And that will get me going there. And I was thinking, again, it keeps coming back to this fact, I don't know what my status is, and with the cover on, the lid on, I can't see my GPS receivers. So they have, lots of flashing blue lights, but I can't see any of them. So again, I'm going to pull out that LED strip that I demoed one time. It's just, it's got 8 addressable LEDs that runs off a single wire from an Arduino Nano. And I pulled it out, was going to use that, and I couldn't get it to do anything. I realized the wire had broken, the power wire had broken off the LED strip. So I just have to solder that back on. And if I plug that in, I just send it strings and say, you know, you send it 8 numbers, comma separated, and each field, you just tell it what color you want the LED to be. And I either broke it into either 8 colors or 16 colors. I don't remember which I used, but so if I plug that one in from any, I could write a ROS node that says, read up GPS 0, read up GPS 1, read up anything else I've got, and just assign an LED to each one of those. So if the GPS is not running at all, it could either be off or be red. And if I've got a total GPS fix, then I can turn that LED green. So just by watching that, you know, so a fix could be green, a float could be something else, and a single point could be some other color. So just at a glance, I can tell what that's doing. So also, I was complaining that my serial interface to the GPS boards is dying for some reason, and I don't know why it's doing that. But here's another thing I can say: if I'm not getting any data from it, then I can just turn the LED off completely for that one. So I'll just have a strip of LEDs, and each LED tells me the status of something that's running on the system. And when you power it up, if they all turn green, then you're ready to go. It's calibrated. It's got correction data. It's everybody's happy. And if any one of them is red or some other color, then I know, well, I got a problem. And there's no sense driving around the block if something's not running. So that I think that would be very handy. And I might try that pretty quick. I just have to, I say, I just got to solder that wire back on, and then I need to make a better one and make one that's longer. I got a strip of LEDs that are really close together. There's almost no space between them. And I can probably get 20 or 30 LEDs across the back of my robot by using that one. It's just that my USB probably will not power that many LEDs. So that's the other problem that I have.
And the Ardu Simple, does it give you a status message at all?
Oh, it gives me page after page of stuff that I can get out of it. So, and in fact, even the message, by the time you put a ROS driver on it, even write in the standard fix message, there's 2 different things that say status in there. And one of them, if it's a 2, you got to fix. If it's not a 2, you don't. And I don't remember what the numbers are, but I can tell from that, you know, the actual fix status of the GPS. I can get right off that fix message. And
the LED would just give you a visual of that.
Yeah, because see that gets into ROS, but then you still don't know unless you're watching the screen or you have something specifically watching that. So you could write up just someone was talking about this one time he wanted some kind of a testing or verification node that basically you have one node that looks at a lot of different things, and you pick off whatever values you want, and then I think he was writing that to a file or putting it on the screen or something. But I can just have that one node would then talk to my LED strip. So it says, okay, LED number 3, change it to this color, and something else happens. So LED 1, change it to this color. So I think that should be relatively simple to do, and it's just a matter of, you know, working through the steps and verifying that works.
Now, in the automotive world where I spent time, they did a lot of what they refer to as visual controls. So it was always useful to be able to look instead of read a computer screen. Cool. Well, I'm hoping to get some time to work on this. We'll be also driving to Texas, hopefully over the next few days. So also be in Texas trying to work on lawn tractor number 2 down there. So we'll try to get it going too. So we'll see where we make progress at the next few days. So if you do stumble across that IMU thing, let me know. I'll be taking my electronics with me, just probably not the tractor itself, since I have another one down there to try to get going physically. So
Do you have enough spare parts down there, or do you take parts with you when you go down, or how do you do that?
I have the motor and the transmission servo with the super servo down there, and so they're not spare parts. I think I have the pieces to make it physically move. So that's, I got to get it physically moving. And it's a slightly different model. It doesn't have fuel injection, and so the carburetor is a little bit different configuration, but I think I have everything I need to get it to physically move. I had the motor mounted, and the shaft, the steering shaft, I think the last time I was there, made that pin, drilled the hole in the steering shaft and mounted the high tensile bolt through the steering shaft. And so I think I'm ready to turn the wheel and put it under digital control and test my magnetic sensor for sensing the steering angle. So yeah, I got all those pieces. You just gotta, I think you would call it integrate all of those pieces together. Tons to spend tons to spend time on.
Yeah, as you were talking, I was sitting there watching my lights flash, and I think there's one more thing to add to the mix. I think the camera itself on the computer is very quickly trying to adjust, so I think that's amplifying the problem. So number one, it's an air conditioner. Number two, it's my LED lights. And number three, it's my camera is doing funny things to me. So that's why it looks so drastic on the screen.
Yeah, you can rewatch the recording and see how often it's flickering, because it's flickering a lot.
Yeah. And it could be I do have power problems in my neighborhood now, because I've got two air conditioners real close here. There's one, it's probably a separate cable coming into the house, but it's physically right next door in a duplex, and right behind me there's another duplex, and I think when theirs turns on and off, I may see that too. So because all this goes back to the alley where all these cables plug in, and the wiring in this neighborhood is just crap. They've got like 3 or 4 transformers all wired in parallel for the 2 blocks, and all the wires that supply all the houses, the insulation fell off those years ago. So if the wind blows, they touch together, you get big sparks, and eventually they touch together and it shorts everything out. Then it takes them a day to come out and fix all this stuff. And they won't put in new wires. They just keep patching it. So that's why I kept thinking when it's flickering a couple of weeks ago, I thought, well, maybe my power is going to go out. But then I decided, well, it's maybe just the air conditioners doing that. And now the power has gone out and it came back and it's acting funny. So we'll see what happens.
That's a fire hazard.
Well, at one point, something did short out, and all the wires for like half a block were smoking. It wasn't enough to blow the main fuse, but it was, the wires got hot enough that they're smoking, and probably if it was a night, they'd be red. But that's, I just say, it is a fire hazard. And every once in a while, the wires break and fall down. And one night a wire was broken and hanging down in the alley, and I went over and looked at it, and I took somebody's trash cans, these plastic trash cans, and put up next to it so nobody would accidentally walk into it, because I knew there was still power on that. And so I was outside, I heard this crackling and popping, and I went running over there. One of the local drunks had come home in the middle of the night in the dark, and he was trying to grab that cable and move it around, and it was sparking. So I carefully explained to him, don't do that or you'll die. And then I finally waited hours, stood out there making sure nobody else touched it. And the power company finally showed up. The guy was in his truck. He looked at it and says, oh, okay, we'll be back tomorrow to fix it. And I thought, well, but that's a live wire. It can't be live. See, it can't, because it's the ground return wire or whatever it was. He said, oh, it can't be. Well, I knew damn well that had power in it. So then they came out the next day to work on it. The guy climbed up there, he started moving around, and bam, it started sparking, and they're going, hey, it can't do that. And I pointed up and says, look right there, it fell on top of another wire. That's why it's doing that. They go, oh, so that's the kind of crap that I have to put up with. Same as any industry, I suppose. That's they know it's not a problem until they grab it and they find out they almost die. I'm sure that really surprised him when that happened.
That is that their insurance company would not want them to be to be handling it that way. Trust me, 'cause your insurance company are the people who would have to pay out. Not
Yep.
good. Not good.
So I guess I
Okay.
don't have anything else.
Well, good luck this weekend.
Okay. See you
Talk to
later.
you later.